Welcome back, y'all. In this video, I will be processing some waste asbestos. What I mean by that is, well, it's very simple. I boil it in water, blend the resulting pulpy goodness in a blender until it's a sludge, and squeeze the water out through a cotton rag. Then I boil it in dilute hydrochloric acid, squeeze the acidic water out the same way, boil it in water again, squeeze the water out again, and dry it in a toaster oven. Once dry, I first used a coffee grinder to grind it into cancer fluff, but it gains so much volume that it took a while to do the first batch. After that, I used the blender dry for the same thing. That's pretty much everything I do for this video, and I've read a lot about asbestos over the years, so I'll talk about some of its historical uses and why it's been phased out. First off, what is asbestos anyway? And the answer depends. There are multiple different kinds, but the main kind that's used is Crucible, which has an ideal formula of this, so I guess it's a magnesium silicate type mineral. It's highly temperature resistant and is the only mineral that can be easily made into a cloth. I might do a deep dive and make a video just on the history of asbestos because it's just so broad and interesting, but we'll see. I bought a bunch of asbestos cloth a while back, and I've used it to insulate whatever needs insulation in my lab whenever aluminum foil won't suffice. This includes beakers on a hot plate, for example, and sometimes solutions overflow and get the cloth wet. Depending on what the solution is, it can have next to no effect on the cloth if it happens once, but when it's something strongly acidic or basic, and or if it happens multiple times, the cloth becomes brittle. If it becomes brittle, it doesn't work as a cloth because it won't flex, duh, and when you try to, it breaks. When it breaks, it gives off lovely little fibers that human lungs really like to hold on to. And by that, I mean you get an extremely aggressive form of cancer called Mesothelioma after like 2 to 5 decades, and it's not fun. It's very difficult to effectively treat, so if you get it, there's an approximately 90% chance you die from it within 5 years. Another less severe condition caused by inhaling asbestos is, get this, asbestosis, which is characterized by inflammation and scarring of the lungs. It's kind of similar to silicosis, if you know what that is. Generally speaking, I'm not super concerned with every single recommended safety precaution and PPE for a lot of the chemistry I do. I wear gloves most of the time, but otherwise there's just not that much I do. This, though, I don't fuck around with, and I'm wearing a respirator behind the camera when I work with asbestos like this. It'll become especially obvious why I wear one later in the video. Why, you ask, am I processing waste asbestos? To speedrun mesothelioma, obviously, it's in the title. Nah, because it's useful, and I had this waste stuff lying around and thought I might as well make a video about it because I like talking about asbestos. I won't say specifically what I intend to use it for, as that'll be in a future video. I've read a lot of older chemistry and chemistry-related textbooks, and asbestos was used everywhere. It was especially useful in quantitative chemical analysis as a filtering medium. Where paper filters couldn't be used, like if the precipitant needed to be strongly heated in the crucible it was filtered through, or if the liquid was strongly acidic or basic, asbestos could be used. Its fibrous nature makes it an excellent filtering medium for extremely fine or even gelatinous precipitates. With the industry and technology available to us today, we can just make glass filter papers or sintered glass crucible funnels for the same purposes. I don't remember exactly how asbestos was purified for use as an analytical filtering medium after the originally developed procedure, but I know at least hydrochloric acid and maybe later nitric acid was used. Sulfuric acid wasn't used because some of the impurities had sulfates that are insoluble, so they would just contaminate it further, and chlorides and nitrates are generally extremely soluble and easy to remove by following acid boils with copious water washings. I'm not using it for analytical work, so I didn't boil it with nitric acid, just water and dilute hydrochloric acid. Strong bases do technically react with it, eventually dissolving it if they're concentrated and hot enough, or if they're cool and are in contact with it for an extended period of time, so they can't be used to purify it. It can be used to filter pretty much everything other than hydrofluoric acid, and that does include concentrated alkalis if they're not hot, because they don't reside in the filter long enough to react with the asbestos. Boiling with hydrochloric acid should dissolve any iron impurities and magnesium present from the structure you saw earlier. That's idealized. And it leaves a skeleton of nearly pure silica, which is what makes it such an inert filtering medium, and the retained fibrous structure makes it such an effective filtering medium. On a related note, if you know what sealite is, like filtering through a pad of sealite, it's diatomaceous earth that's been purified and treated in a certain way. It functions similar to that. I fucking love asbestos so much, dude. Why can't we have nice things? Why are all the things that are extremely effective at what they do super cancerous or otherwise terrible for us? With the remaining time, let's talk about Gooch. Not the guy from Diana's TikToks. Frank Austin Gooch was an American. Yeah, imagine having that fucking last name now. Man, that'd be death. That'd be terrible. Anyway, he was an American chemist and engineer that invented is now known as the Gooch Crucible. The name stuck with the style, so sintered glass crucible funnels like this are also referred to as Gooch crucibles. The original Gooch crucible was made of platinum with a perforated base, sometimes porcelain instead of platinum in the rare cases that platinum couldn't be used. A side note on platinum labware though. So much of it was used for analytical chemistry. It's wild to think about today given how expensive it is. It was expensive then too, but platinum didn't have the plethora of uses that it does today in like catalysis, so it was relatively less expensive. Almost half of all platinum sold in 2014 was, and I guess is, used for vehicle emissions control devices, which is a blanket term that catalytic converters fall under. For perspective, several articles and a few books that I've read, I think when preparing ultra-pure water or sulfuric acid, nitric acid, hydrofluoric acid, even hydrazine and other things, say to use a platinum distillation apparatus, which is nuts. It's nuts because of how fucking expensive it is, but if you look at copper stills for moonshine or alcohol or whatever, it's one of those, much thinner, made out of platinum. Okay, back to platinum Gooch. You take asbestos, scrape it to a fine short down with a knife blade, boil it with hydrochloric acid, wash with water by decantation, and set aside. Then, you stretch rubber tubing over an appropriately sized funnel, plop the crucible in the opening, and put the funnel into a filter flask. A vacuum is applied, and the previously treated asbestos suspended in water is poured into the crucible. The suction creates a felt pad of asbestos in the bottom of the crucible. The thickness of the felt can be varied depending on the nature of what's being filtered. For crystalline meals, it would be a thin layer. For fine precipitates, it would be a thick layer. The crucible containing the felt is ignited and can then be used for the estimation of precipitates. There's more on its use and some variations, but that's beyond the scope of this video. A while ago, probably close to a year now, I mentioned my interest in potentially making videos related to the history of chemistry, some of the chemists of the days over the years, and I think the first one I make will be about Gooch's paper on his crucible, and I think it is in the public domain, but I need to look into how and if I can even use screen grabs from the paper. I just have to check the terms and conditions on a specific website. But anyway, there's your asbestos trivia for the day. Thank you for watching. If you enjoyed this video, like, comment, and or subscribe. I appreciate it. It really helps me out. And I'll see you in the next video.